Greetings and welcome to the introduction to astronomy. In this week's special topic in astronomy, we are going to talk about the brown dwarf stars and try to understand a little more about what they are. So let's get started. And we want to look at, first of all, what is a brown dwarf star? Well, if we define that, they are stars that are generating energy from the fusion of deuterium, but not from ordinary hydrogen. Now, deuterium is hydrogen with an extra neutron. It's a heavier form of hydrogen, but it has a much lower fusing temperature of about 1 million degrees as compared to about 10 million Kelvin for hydrogen. So it fuses at a lower temperature and generates energy. And that's generally what's considered the difference, the dividing line between the stars and the brown dwarfs. The mass range for them is between 13 and 80 times the mass of Jupiter. So we see the little chart here shows that we have planets and exoplanets, which are things that are up to about 13 times Jupiter's mass. These are then not massive enough to be able to fuse deuterium and are classified as planets. Brown dwarfs are things that are able to fuse deuterium, but not hydrogen, and they run in that middle range. And then stars, something that is actually a star fueled by the nuclear fusion of hydrogen gas, would be at least 80 times Jupiter's mass. Now, brown dwarfs were actually theorized back in the 1960s, but the first detection was in 1988, and that was the brown dwarf known as GD 165b. Now, the brown dwarfs are actually relatively difficult to detect because they are not fusing hydrogen. They are much lower energy and therefore harder to be able to see. But we can see the image of one here. We can see the very red dot down toward the lower right there of this, towards the bottom in the lower right. That is the brown dwarf star. So they can be imaged, but they are very faint compared to the ordinary stars. In this case, we have a binary system with two of them, and that allows us to see both of them together there. Now we can classify the brown dwarf stars just as we classify stars. And there's a little bit of an overlap here where we have class M, which are the most massive brown dwarf stars. Well, class M are also the coolest of the ordinary stars. So there are some subdivisions there, but there are some brown dwarfs that are classified as class M. Then you have lower masses, class L, T, and Y, which get progressively lower mass and then would give progressively lower temperatures. And of course, while we've detected some, there are still a lot of them that have not been detected, even ones that are relatively nearby to us here in our solar system. And again, that is simply because they are so faint, so hard to see, that you have to be really doing surveys specifically looking for objects that are very bright in the infrared. Because of their cool temperatures, they will be emitting most of their light in the infrared portion of the spectrum, as compared to ordinary stars, which often emit most of their light in the visible portion of the spectrum. So again, we have thousands that have been detected, but there are still a lot more, and we're only just beginning to find these objects. So let's go ahead and finish up with our summary. And what we've looked at today is that we have the brown dwarf stars, and they are objects that are able to fuse deuterium, but not hydrogen. They are unable to fuse hydrogen into helium, which is the distinction of a regular star. Now the classifications can be M, which overlaps with ordinary stars, and the new classifications of L, T, and Y for the even cooler stars. They emit little energy, and most of what they do is in the infrared, which makes them rather hard to detect. So that concludes this discussion on brown dwarf stars. We'll be back again next week for another special topic in astronomy. So until then, have a great day, everyone, and I will see you in class.